Alright, so now we're going to start getting into chapter 10, which is going to be on inheritance. So to start off with, we're going to take a look at precisely what inheritance is. We'll see a very simple example. We're dealing with just one class inheriting from another class. We'll kind of expand on this to see a sort of hierarchy of classes that all inherit from each other in some way. We'll eventually move from that to looking at sort of further abstracting breakdowns of dealing with inheritance. So we'll move from dealing with just classes to abstract classes all the way to interfaces. And as we get into interfaces, we'll also talk a little bit about the many different ways that you can go about implementing an interface, which will include things like private interclasses, anonymous interclasses, and lambda expressions. So to get started with this, we're going to go ahead and take a look at precisely what inheritance is. So classes are going to be able to inherit the fields and methods of other classes. The primary purpose behind inheritance is generalization for the class that you're inheriting from versus specialization, which is the class that is going to inherit something. So specialized classes are going to be one type of a more general class, we'll say. You can also think of this as a relationship. For example, as we'll see in a little while, we might use some expression like a square is a rectangle. So square is the more specialized class in this case, and then rectangle is the more general class. So that tells us that square is going to inherit from rectangle. So there's going to be two halves of this relationship, the superclass, base class, or parent class. So there's many different terms you can use to describe each one of these. In most cases, I will typically refer to the class that is being inherited from as either the superclass or parent class. And then the other one is going to be the subclass, derived class, or child class. In most cases, I'll just refer to that one as the child class. Occasionally, I'll call it the subclass. So in this example given, rectangle is going to be the parent class, and square is going to be the child class. And so the best way that you can think of this relationship is to remember essentially the same as it would be in the real world. A child will inherit from their parents, whether that means you could interpret that as how a child will inherit the genes of their parents, or maybe how they just inherit wealth or a fortune or something kind of like that. So to now kind of look at this in programming, to specify that two classes have this relationship, you will use the extends keyword in the class header of the child class. So in this case, we said that square is going to be the child class. So we want to say that public class square extends rectangle. So some fields and methods may be inherited from the parent class, which will help to kind of reduce duplicate code. So when we do this, we'll essentially have access to those fields and methods. Additionally, we can actually add fields and methods to the square class to make it more specialized than the parent. So to go ahead and get started with this, I'm going to go ahead and minimize this. We'll come over to NetBeans. So I've got a project for this open already. So we're going to be making use of a couple of things in this project. The name of it is going to be Shape Demo, since by the end of this I'll add more classes to this, and we'll kind of have a full-blown hierarchy of classes, at the very top of which is going to be this shape that we'll see a little bit later on. But for now, the two things that I've got in here right now are going to be this rectangle class, so something that you've probably already seen a few times at this point. In this case, I've gone ahead and kind of reduced it down to essentially everything before Chapter 8, with the one exception being that I went ahead and just kept the copy constructor just for its own sake, really. But essentially what we've got here, we still got our length and width fields, so we'll be able to access those for any child classes that inherit from rectangle. We've got our norgs constructor, our parameterized constructor, our copy constructor. We then have our different getters and setters, so things like get length and set length, get width, set width, and then also kept that get area method at the very end. So we got that. Additionally, we've got shape demo. So this is essentially going to be used to hold the main method. This is where we'll construct any of our objects and then do something with them. For right now, I've gone ahead and just left this empty, so we'll kind of come back to this a little bit later. The other thing that we want to go ahead and add to this now is going to be that square class that's going to inherit from rectangle. So we'll go ahead and create that now. So just go ahead and choose this shape demo package. We'll go ahead and create a new Java class, and we'll call this one square. Click finish. And right here, let's go ahead and get rid of some of these extra comments that we don't need. that. So the very first thing we want to go ahead and do is modify the method header so that the square class will extend the rectangle class. So we're going to use that extends keyword right here, and then we're going to specify rectangle. So at this point now, because we've added this little bit of code, now square is going to access or essentially inherit everything from rectangle. So basically at this point, because we haven't added anything new, you could kind of imagine the body of square basically being identical to the body of rectangle. The difference here being that we didn't have to explicitly write any of that code. It's all just being inherited automatically because we added this little bit right here to the method header. Okay, so go ahead and save that. We'll come back to this in just a moment to start adding some code to it. So in our example of a rectangle and a square class, the following fields and methods help demonstrate each of these 2 points. So if we imagine that we're getting that length and width field of the rectangle class, those are going to be inherited by the square class. Another thing we could go ahead and do a little bit later on, if we want to go ahead and add some additional methods to the square class, because we're working with a square and not a rectangle, we don't really need to worry about the distinction between a length and a width anymore. The expectation is that a square has 4 equal sides. So instead, we could just use something like getSide or setSide, which is going to set essentially the length and the width to be equal to each other. If we're dealing with our UML class diagrams, we're going to have an arrow with an open arrowhead to indicate inheritance. The arrow will point from the child class to the parent class. So you can think of it as forming a statement kind of like this, where we say the child inherits from the parent, and then the arrow is kind of pointing in the direction of that sentence. So then if we actually see this fully fleshed out, then we would get something kind of like this for our UML class diagram. So on the right-hand side, we see our rectangle class. We've already dealt with this before. We've got the name rectangle, 2 fields, a length and a width, and then the different methods. So we've got a couple of constructors. One difference is that I've kept the copy constructor, but that's not present in this UML class diagram. In addition to that, we've also got our getters and setters for the length and width, as well as that getArea method. And then for the square, the fields are blank because it's just going to inherit the length and width from rectangle. We then have our 2 constructors for square, so we'll go ahead and make those in a moment. We've got a getter and a setter for the side of our square, and then we also have a getArea method for the square. Okay, so before we get into all of this, let's go ahead and actually take advantage of what we've got right here. We'll go ahead and actually put together the square class. So let's go ahead and minimize this. Come over here. So the very first thing we want to go ahead and do is include a constructor, so maybe a no-args constructor to begin with for square. So we're going to say public square, take no arguments, and right here what we want to go ahead and do is include a single line of code. Just go ahead and set the values for the length and width. So since we're going to be inheriting those fields from rectangle, it would probably make sense if we just did something like this dot length and say this is going to be equal to maybe something like 1.0, and then say this dot width is going to be equal to 1.0. So you want to try to do something like this, but as you might have noticed right now, there seems to be an error with me trying to do this. So if we do a quick double check, so it's going to say length has private access in rectangle. Well, that's not really what you were hoping for, since the expectation is that square is going to inherit those fields, so them having private access in rectangle seems like it shouldn't matter, but in actuality it does. So the problem here is that because the length and width are private, this means that only the rectangle class can ever access these. So even though square is inheriting those, it still cannot directly access them because they're private. So instead, there are 2 ways we can resolve this. One of those is by modifying that access specifier to use something that allows square to access it. We'll come back to that idea a little bit later. So instead, we're going to go with the next alternative, which is to rely on the getters to be able to get that data from rectangle. So what we're going to go ahead and do is just say this.getLength instead, like so. And so, or I'm sorry, this dot set length. go ahead and get rid of this portion, and we'll go ahead and just put the 1.0 right here. We'll go ahead and do the same thing with width. So we'll go ahead and say this dot set width. Just go ahead and move the entire line, make this a little bit simpler, and just put the 1.0 there. Go ahead and save that. And so this way then, by just relying on the set length and set width methods, we can just go ahead and set it accordingly. Alternatively, if you don't want to use set length and set width, you could also just use the this keyword to try to set that that length and width through one of the other constructors. So maybe if you want to try and do it that way, let's see what happens then. So let's say instead of doing all of this, we just want to say this, and then we want to do something like 1.0, comma 1.0. So this is what we want to try to rely on. But again, we run into a bit of an error. So what is it this time? So in this one, it's saying square or constructor square and class square cannot be applied to given types. So the problem we're having now is that it doesn't see a constructor that matches up with what we're trying to do here. The reason for that is that if we're using this, in this particular case where we're dealing with the constructor, it is always going to assume that we mean a constructor in whatever the current class happens to be. So instead of relying on this, what we need to rely on instead, that we're going to go into a fair bit more detail in the next video, is going to be the super keyword instead. So another way that we can go about using the constructors is to do super. And what this is going to do is it's going to look at the very next class in that hierarchy, so wherever this extends, say like rectangle in this case, and then it's going to look for the appropriate constructor in that class. So in this case, you can basically imagine this as if it were making a call to the constructor saying that you want to make like a new rectangle object. And you're going to go ahead and give it a length and width of 1.0. So if we come over here, we can see that right here, where right here, with the parameterized constructor, where we're giving it a length of 1.0 and a width of 1.0, and then we'll go ahead and set those right there. So that's essentially what we're trying to accomplish with this one. And then we can go ahead and do the same thing with the parameterized constructor. So we'll do public square, and then we'll go ahead and put in something like double for the side. And for this one, again, we can go ahead and rely on this super keyword and say that we want to just go ahead and set up the side in this case. The next thing we're going to go ahead and include is going to be the get side and set side methods, and then finally the get area method. So we'll go ahead and do public. In this case, we want to do something like, let's say get side first. So we'll do public double get side. And for this one, all we want to do here is just return essentially either the length or the width. So either one of those would qualify as the side of our square, keeping in mind that we need to rely on the fields that we're inheriting to accomplish this. So we could go ahead and say something like return this dot, let's say get length in this case, and then that'll go ahead and just give it essentially the equivalent of a side. Additionally, we can go ahead and do public void set side, again passing in something like side to provide an amount to go ahead and set that to. And for this one, we can go ahead and just use, in this case, now we want to go ahead and rely on this dot set length and this dot set width, and we'll go ahead and put in the side for each of those. So in this particular case now, since we're not constructing the object, we can't do the same thing that we did for our constructors. Instead, now we have to rely on set length and set width to accomplish this. And then finally, we want to go ahead and include that get area method. So we'll do public void or public double get area. This won't need to take any arguments. Instead, all we need to do is just return this dot get length multiplied by this dot. It doesn't really matter too much what you multiply it by. You could just do length times width. In either one of those cases, it would give you the area of the square because, again, all of the sides are supposed to be equal. So we could just imagine that we're doing sort of like side squared. So we'll just say this dot length multiplied by this dot get length. where it's essentially kind of like squaring the length to get the area of that square. And so then what we could go ahead and do is actually construct one of these squares and then maybe print out its area. So let's go ahead and try something like that. So right here, we'll just go ahead and make a single square object. So say something like square. We can give it a name like, say, SQR, for example. It's going to be equal to a new square. And then right here, we can go ahead and give it a length or a side. And then that side will go ahead and set both the length and width. So let's say maybe for this one, we go ahead and give it something like 9.0 for the length of its sides. And then right here, we'll just go ahead and print out the area. So say system.out.println. We'll say something like the area is plus our square, which is sqr.get area. Go ahead and save that. And so now if we go ahead and run this, what it will do is construct this square object with a side of 9. SQR is going to be the reference to it. We can then go ahead and access that using SQR, use the get area method. So we can go ahead and say that the area is, and in this case, it should be 81. So go ahead and run that. Move this output up a little bit. And we can see right here, the area is 81. Okay. Okay, so continuing on, the constructor of the parent class, or superclass, is always going to be called before the constructor of the child class. If a superclass is either a default constructor or a no-args constructor, that constructor is automatically called just before the subclass constructor executes. So let's see if we can take a look at precisely what is happening with each of these 2 points that are being made. So go ahead and minimize this, come back over here. So if we take another look at square, so we kind of set up the constructors for square already to take advantage, at least a little bit, of that super keyword. So let's say, for example, we don't do this little bit right here inside of our no-args constructor. Let's say that we remove that and we go ahead and save it. Well, right now we don't see any errors with this, so it seems like everything is okay. Let's go ahead and run this now and see what happens. Let's say, before I run that actually, go ahead and change this so we can actually take advantage of that no-args constructor by actually calling it here. So the expectation, if what it is suggesting will hold true, then we're going to implicitly call the no-args constructor of rectangle, which would be this constructor right here. This will go ahead and set the length and width to 1.0. And so then for this area right here, we should expect that to be 1.0. So if we go ahead and run this now, then we can in fact see that the area is 1.0. Additionally, what we can take a look at is the order that it's going to call these constructors in. So to see that, let's say that I go ahead and modify my no-args constructor right here. So we'll say something like system.out.println. Let's say calling rectangles no-args constructor. Go ahead and save that. And then if I go back over to square, I'll do the same thing. So right here, say system.out.println. I'll say calling squares no-args constructor. Go ahead and save that. And so now, when I make this call right here, so this is on line 7, this would be just before this statement is printed to the console. So now, the order that I should expect to see these in is this statement inside of rectangles no-args constructor first, and then this statement inside of squares no-args constructor. So if I go ahead and run this, now we'll see right here calling rectangles no-args constructor, and then followed up with calling squares no-args constructor. So we can see that the order is actually with the superclass constructor first, and then the current class's constructor. Okay, and then the final thing to mention about inheritance, keep in mind that it does not work in reverse. So while a child class inherits from a parent class does not inherit from a child class. So this means that a parent class cannot call the more specialized methods implemented in a child class. So even though we could go ahead and access methods within the rectangle class from the square class, as we already saw with the constructor method, we cannot do the opposite. So there's no way that we can access some new specialized method that we introduce in the square class, say like getSide or setSide. We cannot access those methods from the rectangle class. So the end result here is that parents do not inherit from their children. Okay, so that'll kind of wrap up this introduction to inheritance. In the next video, we're going to go into a fair bit more detail about the superclass constructor, and we'll discuss a little bit more about some of the different rules and constraints that come with calling that superclass constructor.